What's up, guys? Welcome to my new series over AMC 8, 10, and 12 problems. In this series, I'll be exploring AMC, or American Math Competition problems. So, the American Math Competition is basically one of the biggest national math competitions that relies on logical reasoning and thinking. So, let's jump into one of the hardest problems on the AMC 8, which is for 8th graders and below. It's particularly hard because it's based on the Collatz Conjecture, which is the unsolvable math problem. Okay, so when a positive integer n is fed into the machine, the output is a number calculated according to the rule shown below. So if you input n, a number, if that number is even, you have to do n divided by 2. But if it's odd, you'll do 3n plus 1. For example, take 7. You have 7, so that's odd, so you do 7 times 3 plus 1, 22. Then you would divide by 2 because it's even, so on, you just repeat the process. So when the same 6-step process, so the process of 6 steps, is repeated to a different starting value of n, the final output is 1. What is the sum of all such integers n? So how would we approach this problem? We know that there's multiple, possibilities for n, so we can't just substitute 1, 2, 3, 4, 5, 6, 7. That would take years, months. We only have about 1 minute per each problem on the actual exam. So the best way in problems like these is to work backwards. So let's work backwards and see all of the possibilities. So for example, we'll do 1, right? So what can you have to equal 1? Well, you can do n is 2 because, right, 2 divided by 2, that's going to be 1. So you have 2. And that's pretty much your only option. It can't be 0, right? Because you can't divide a positive integer by anything or add anything to get 0. Okay, so how many ways are there to get to 2? Well, we could have 4, right? 4 divided by 2. And yeah, that's it. We can't do 3n plus 1 because look, 3n plus 1 equals 2. That means 3n equals 1. But that's not an integer, is it? It's 1/3. Okay, well then how many ways are there? Rewrite this down here. How many ways are there to get to 4? Okay, well we can do 8 divided by 2, obviously. Can we do odd? Yes, we can. In fact, n can be 1. 3 times 1, that's 3 plus 1, 4. Okay, let's just write this here. Okay, so how many ways are there to get to 1? Well, we can get to 1 by doing, we already did how many ways there are to get to 1, so it's just 2. And how many ways are there to get to 8? Well, we can do obviously 16, right, divided by 2. And yeah, that's pretty much it. Okay, so this is 1, 2, 3, 4, 5. We are now on our last stage, which is going to be n. So how many ways are there to get to 16? Well, we have 7 steps, right? 1, 2, 3, 4, 5, yeah. Okay, so how many ways are there to get to 16? Well, we can do 32 divided by 2. And we can do 5 as n, right? 3 times 5 plus 1, that's 16. Now how can we get to 2? We already calculated that here as well. It's just 4. Okay, now we are finally at n. Yeah. So how many ways can we get to 32? Well, we can do 64 divided by 2, right? What else can we do? We can't do 3n plus 1 because that would be 3n plus 1 equals 32. 3n equals, what is it? 31. That's not possible as an integer. So how can we get to 5 now? We can do 10, right? 10 divided by 2 is 5. And we can't do anything for 3n plus 1. Now 4. How can we get to 4? Well, we already calculated that here, right? We can do 8 and 1. So 8, 1. So now we finally have all our options. And look, it's just simple addition. So 64 plus 10, that's 74, right? These two. 8 plus 1, that's 9. 74 plus 9, that's 13. Carry the 1. 83. So our answer is going to be E, 83. So I hope you guys love this explanation, as I just broke down a really hard AMC problem, which in the end was just addition. So the key thing was to work backwards instead of working forwards. And that's what the AMC is about, thinking smartly. So stay tuned for my future videos and make sure to like and subscribe, as that would help me out a lot. Thank you.